Douglas is getting close to the Hawaiian Islands as a pretty significant hurricane, probably category 1 or 2. I'd say 2. There's a lot you can see in this imagery to do with the islands and the topography. First of all, I'll just mark on the two high mountains of over 4,000 meters, Mauna Kea and Mauna Loa. And then on Maui, you've got Haleakala. There's actually another mountain that's over 3,000 meters on the Big Island, adding to the blocking effect. When we look at the clouds, you can see the blocking of the island. It's blocking the lower tropospheric flow into banded clouds moving around. In the lee, the air comes round and converges, and on both sides you can see these downwind clouds, convergence clouds. It's another one for Maui. It's less evident for the smaller islands because their mountains aren't high enough to really block the lower tropospheric flow, and you can see that with the clouds over Oahu. They're just streaming over rather than getting blocked and going around the side. This is all important for hurricane steering. These smaller islands will have very little impact on the steering of a hurricane, but the larger islands have a potential for a larger impact because the lower tropospheric flow is getting blocked almost entirely, and you can see the mountains peaking up above the clouds, and this affects the steering by essentially pushing the air and pushing any vortex or in a different direction. Currently, the Central Pacific Forecasting Center has the storm coming in and going on a track very close and even over Oahu, and it maintains hurricane strength during this period. Now, because of that, they've issued a hurricane warning for Oahu, and of course they have to, because the models have it on this track and it's a hurricane strength that goes into here. However, we have a historical precedent and due to modeling studies to suggest that something unusual may happen in this region as the storm begins to interact with this blocking flow around the Big Island and around Haleakala. Now, what happens here is an unknown. So, I can't tell you what's going to happen. But we have a historical precedent of a weaker storm, and what happened was, as I mentioned in the previous video for Tropical Storm Daniel, is that the storm actually moved well north of the forecast track and went north of the islands, clearing the islands, giving virtually no impact. In this case, the storm is stronger, and one of the key things that happened with Tropical Storm Daniel is that in this region it actually intensified and reformed into a hurricane, a category 1 hurricane. The core contracted and it wrapped out in intense convection, allowing the intensification to occur, the re-intensification. Will this storm also jump north a bit and also show some signs of intensification in this region? My suspicion is that the reason why Daniel in 2000 intensified in this region is due to interaction and jump north, interaction with the blocking flow, and the intensification, well, as this air is blocked and this air upstream is not blocked, so we have reduced flow here and then normal flow here. In an environmental sense, this is actually causes convergence in this region. So potentially that could be a mechanism for intensification in this region. So overall, what we're looking at here and what we're looking for in order to learn from past mistakes and to build a better forecast for Hawaii We want to see what this storm does. It's really a rare case, and will it do something similar to Daniel, or will it hold on to the model forecast track? The forecasts now have improved since 2000 a lot. That was 20 years ago. And now the topography should be better resolved, so perhaps the models are going to do a better job this time. I don't know, obviously, and so what we want to look at to see if the models are doing this well is look very, very carefully at how the hurricane behaves in this region. What we're looking for is any jumps north in track, and we're also looking for any signs of disruption to the vortex, possible intensification, possible disruptions to the convective core or contractions of the core. That's another thing that we see in simulations. And so let's keep a real careful eye on this. Remember the forecast track, and remember and note any changes that happen, and then we can move forward